Hello and welcome back to The Space Between, one of the top astronomy podcasts in the world, and for that matter, the universe. My name's Kolby Van Camp. No Dawson Wagner today. Dawson has flown the coop. He's gone down to Mexico for a familial vacation, so all the best to Dawson while he is out of the country. Instead, today, I've got a good friend of mine, Jimmy Kaufman, who's joining on the show today, a student at Kansas State with me as well. And Jimmy's a real natural for radio and being behind the microphone. You can check out his podcast, Dialed In, on wildcat919.com/podcasts, and you'll be able to find all of the information that you could ever want on Jimmy and his sports takes, I guess you could say. Yeah. So, Jimmy, appreciate you coming by the show today.
Wow, yeah, thank you so much for that intro. That was so kind. I appreciate it.
Yeah, no problem.
I'm excited to talk some space.
Yeah, it's fun. So today's a little bit of a laid-back episode because Dawson's not here, and we're just going to be talking about some really interesting stuff that's been happening in the science community over the last couple of days since our most recent episode. Hope you enjoyed the latest, where you decided that episode 16, where we talk about radio telescopes and our announcement that we're going to the VLA in New Mexico, the Very Large Array. We're going to make that the start of season 2 for the podcast. So episode 16 until February of next year is going to be season 2 for the podcast. So that's exciting. The podcast first anniversary is coming up here at the end of the month. We'll probably record some special content just for that. And if you want to stay up to date with that, go check out our Patreon. Go to www.spacebetweenpodcast.com. That's where you can find all of the information you could ever need about joining our exclusive Patreon community. And the way that you do that, it's easy. You can join for $2, be a part of our Discord. You can join for $5 and get all of our exclusive content. And that's only $5 a month. I'm not real big into pay me $70 a month to join my Patreon. We're not that kind of operation. I don't ever want to be that kind of operation. I'd rather make money from merchandise, or I'd rather make money from an opportunity to go and get some sort of sponsorship or something like that. But our Patreon is a way for us to fund what we're doing, especially going down to the VLA, because that's expensive. So if you want to join the party, you can do that and join into our quantum computer Discord server, which is pretty awesome in and of itself. If you aren't following us on Instagram and TikTok, go do that at Space Between Pod, Pod. And if you want to engage with us in any way, please do so. We're wanting to get to know you and our community a little bit better. We've eclipsed 3,000 streams just this week. So a round of snaps for everybody involved with that. We appreciate just our consistent listener base. We have close to 100 people that just consistently listen to us every day. I teach a podcasting class at Kansas State, and one of the things that I was telling that class is consistency. One of the big things about podcasting is consistency. I realize we haven't been particularly consistent because of the deaths in my family and just the stuff that's been happening in the last couple of months. But consistency are where Dawson and I are trying to get back to. So we're really excited to bring consistency to you. And that starts today with all of our new content and an update for you that we're going to be dropping our new episodes on Mondays now. I found that recording on Friday, trying to crank it out by Friday and then enjoy my weekend, it just wasn't working for me. I have time on the weekends. I'm going to take the 2 days to then take everything that we recorded on Fridays and then spit them back out for you on Mondays. My final update is that it's more of a personal one, but I've started selling my astrophotography. If you would like to get a print of my astrophotography that I do, it's original work, you can go to my website, www.kolbyvancamp.com, VANCAMP, like the pork and beans here in the United States. And I wish I was a part of that dynasty. I am not. But if you go to that, kolbyvancamp.com/store, you can check out a way to purchase my astrophotography prints. And one of the first ones that I put up there is of the Orion constellation. All the details you could ever need to know about that particular shot are on the store. And if you're interested in that, I'd be really humbled to have my work hanging on your wall. So without further ado, we've gotten all of that out of the way. Jimmy, talk to me a little bit about what you know about space and just your interest in the heavens in general, because you're a pretty vibey guy. You're kind of the drip lord around Wildcat 91.9. You've always got the zany outfit on. Oop, need to turn off my computer sound. You've always got the zany outfit on, and I'm excited to hear what you have to say about your thoughts about space.
Yeah, especially growing up, I was a huge fan of everything space. Big Star Wars guy. You know, I know that's not
nice.
It's obviously fiction, but I love all of the talk about, exoplanets and everything kind of beyond our solar system. But I also love things in our solar system. I love astrophotography, and I'm very excited to see some of the astrophotography you do, out there in New Mexico when you go see the VLA.
I'm excited for that too.
Very excited about that. But I took an astronomy class back senior year of high school.
Nice.
So it's been a couple of years since I've been in that field, but I always love keeping up a little bit with some astronomy happenings.
Cool.
Yeah.
So if you had to specifically pick an area of space that you think is most interesting, and I think about it in the context of the way that people take photos of the sky. So you have deep sky astrophotographers, people that are interested in planetary nebulae, reflection nebulae, globular clusters, supernova remnants, stars, kind of that thing. Then you have people that are very solar based, so they really like studying the sun. They like taking pictures of the sun. And then you also have lunar photographers. They're super into taking pictures of the moon and the different stages of the moon. And then you also have people that are super into celestial photography. So just kind of the general objects that are in our solar system. Where do you think you lie in terms of just your viewing pleasure of the night sky? Or do you go somewhere else and you're like, I'm super into cosmology and black holes? Or is it kind of way out there?
Black holes freak me out. Every time I see something with a black hole, I get like a weird, like I can't look at it for long.
Okay.
That's why Interstellar kind of scared me at that one part.
Really?
Of the movie. A little bit, because it's like just thinking about the just enormity of it all. Like I remember it was like on TikTok they'll have those like videos of, it'll be like, here's the size of the star of our star, and then it'll go up, and then you reach like the supermassive black holes. And I think that's when I found out I had megalophobia,
Oh, okay.
Like the fear of like the big stuff.
Interesting.
I know, right? Yeah, it's that part always freaked me out. But in terms of interest, I really enjoy nebulas and nebulae. I love all like the pillars of creation and all that stuff. The Crab Nebula. I love those pictures just because of how vibrant and colorful they are. I love anything. I love like planets in our solar system shot in infrared.
Okay.
Like that kind of makes them glow a little bit.
Yeah.
I saw a picture recently of the James Webb Telescope shooting Jupiter. And it was shot, if I remember correctly, it was shot in infrared. And it was like glowing.
Yeah, they did a couple of different pictures. I think they got one of Uranus as well. That's where it's on its side, and it discovered that it has like a bunch of rings that we've never seen before.
Really?
Yeah, I might, don't quote me on that, but I think that I saw that in the news.
I have seen that picture actually.
Yeah, it's like on its side.
Yeah.
And it's weird. It's like this light blue kind of teal color.
Yeah, Uranus is one of my favorite planets to look at just because of it being on its side. It makes it so unique how it really how everything works just on like a different axis, if that makes sense.
Sure.
I think that stuff's really interesting.
Yeah. So if you were going to go somewhere and it didn't matter and you could just go to a different planet, are you going to Uranus or are you going somewhere else?
I'm going to Neptune, 100%.
Why Neptune?
Just a beautiful planet. It's like just the pictures of it are gorgeous.
Mm-hmm.
How the deep blues. And I'm pretty sure it rains sideways there.
Really?
I'm almost positive.
Really?
It is super cool. Can we get
we'll keep talking. I'll fact check you.
Yeah. It rains sideways. It either does that or it rains glass or it does both. I know there's an exoplanet that does that too. And exoplanets are another thing I'm really interested in. I love like the talks of like super Earths and in other possibly habitable planets. Like all the talks of terraforming Mars in our solar system. I love stuff like that.
Okay, so I'll be interested in getting into that with you here in just a few minutes. But the rain on different worlds, so it rains diamonds on Neptune.
That was it.
There's sulfuric acid rain on Venus. Which is
sense.
kind of horrifying to think about.
They're
like Earth, water, rains water.
Wait, really?
No kidding.
Does it mention the microplastic? No.
Oof. If I had the like Roblox oof programmed into this little roadcaster, I'd have smacked that right there. Neptune has diamond rain. So the rain of diamonds on Neptune, this is according to zmescience.com. And it's affiliated with NASA. The rain of diamonds on Neptune is one of the most spectacular events in the solar system, but it's not exactly what you'd think. Neptune is the 8th and farthest planet from the sun in the solar system. Sorry, Pluto. Neptune's composition is similar to that of Uranus and different from that of gas giants like Saturn, and Jupiter. Neptune's atmosphere is composed primarily of hydrogen and helium, along with traces of hydrocarbons and possibly nitrogen. However, it contains a higher proportion of ices, such as water, ammonia, and methane. Neptune's weather is characterized by extremely dynamic and devastating storm systems, with winds reaching speeds of almost 600 miles per second, which is 2,160 kilometers per hour.
Oh my God.
The abundance of methane, ethane, and ethene at Neptune's equator is 10 to 100 times greater than at its poles. It has been theorized that Uranus and Neptune actually crush methane into diamonds, and lab experiments seem to confirm that this is possible, which is kind of absurd. And I hope that I said that methane, ethane, and ethene. I think I said that right, but if not, I'm sure I'll get dunked on in the comments, so it's fine.
Well, so for rain... So if it's raining diamonds and it's blowing at 600 miles per second, it would rain sideways, would it not?
Potentially. So this is an article from NASA that I found specifically, and I think the planet that you're referencing is actually an exoplanet. It says Reigns of Terror on exoplanet HD 189733b. It's in the article from NASA, which they shared October 31st of 2016. Says this Halloween, it was around Halloween, take a tour with NASA's exoplanet exploration site of some of the most terrifying and mind-blowing destinations in our galaxy. In this image, the nightmare world of HD 189733b is the killer you never see coming. To the human eye, this far-off planet looks bright blue, but any space traveler confusing it with the friendly skies of Earth would be badly mistaken. The weather on this world is deadly. Its winds blow up to 5,400 miles per hour at 7 times the speed of sound, whipping all would-be travelers in a sickening spiral around the planet. And getting caught in the rain on this planet is more than an inconvenience. It's death by 1,000 cuts. The scorching alien world possibly rains glass sideways in its howling winds. The cobalt blue color comes not from the reflection of a tropical ocean as on Earth, but rather a hazy, blowtorched atmosphere containing high clouds laced with silicate particles.
See, I knew there was a planet that did it. I didn't remember if it was an exoplanet or if it was Neptune.
Yeah, it's an exoplanet. Thank you for playing HD 189733b.
Well, and that I've actually perused that a little bit.
Yeah,
all the planets in there. I know there's like a pink Jupiter, hot pink Jupiter in there.
Really?
There's one planet that is made of diamond, and it is so the reason that it doesn't melt because it's very close to its sun, but it doesn't melt because it's so close to the sun that it's so hot it just compresses and stays solidified as diamond. It's insane. Yeah, it's insane. I've learned more about physics through just looking through there than any class.
That's crazy.
It's insane.
That's and that's what I love about space. And it comes down to, you said, at the very beginning, I'm a Star Wars fan, but that's kind of not real. I mean, yes, there's science fiction to it, but that's why it's called science fiction, because it's based in general science that we understand. And, in the 70s when Star Wars first came out, that science fiction was like, whoa, revolutionary. But I mean, a whole generation of people were inspired to go to space because of Star Trek, So science fiction has its place. Do you have an opinion on science fiction in the way that it enhances and detracts from the understanding of science? Because there are still people to this day that I think would watch a science fiction movie and be like, can we do that? It's like, no, no, we cannot. Mr. Sulu, we cannot fly at warp 7.
Yeah.
We cannot fly at warp 1 because it's too fast. It defies what we can currently do with our current technology and our current understanding of the laws of physics. So where's your place of science fiction resting in the hierarchy of importance to getting people into space again?
I think that, I don't necessarily go into a sci-fi movie thinking, oh, we should do this sometime. But I think movies like Interstellar are very important because that movie is one of the most factually correct representations of space in the way that they do that movie. I think movies like Star Wars are cool just for creativity, the possibility of what could be, because we've only discovered just over 4,500 exoplanets out of, just the visible galaxy that we can see from Earth. I mean, It's insane how much is still out there. And I think I would love to see a movie done with the whole idea of exoplanets, kind of like they did on Interstellar, just because I think that's a field that more people should look at and go into and see, because there's so much to still discover.
Yeah, no, I agree. And I think that's the power of multimedia and the power of telling a story and doing it in an accurate way. Because generally scientists looked at Interstellar and were like, okay, like, yeah,
Sure.
yeah. I mean, for the most part, it checks out. I mean, the image of the black hole that we see is purely based off of models that we have today, because the only images that we have of black holes, which we talked about in the previous episode, thanks to the Event Horizon Telescope and radio telescopes and the power to see things that can't be seen because we're listening to them and then converting those frequencies into images, which is just crazy. We don't know what it looks like, though. Like, nobody's seen a high definition image of a black hole, and that's problematic. So how do you make a movie centered around a black hole when you've never seen a black hole before?
Yeah.
And so it's interesting because there's some liberties that have to be taken, but the general physics behind it, I think, is fairly well documented, that for the most part it works. Is it the most foolproof, airtight thing ever? No. But is it pretty dang close?
Yeah.
Yeah, I think so.
Well, and when you're making a movie, sometimes you got to go out of the bounds of reality just to make a good, cohesive
Or the movie
story.
would suck.
Yeah, exactly. Which is where it's like going to a movie not expecting to necessarily learn. But, I think space movies, science fiction, it always piques my curiosity. It was always kind of like, wow, that could be out there. Oh, there might be stuff like that. I'd like to go, do some research, look at other planets that are just outside of our solar system. And I think what's so cool when you look at exoplanets is anybody could find them.
Yeah.
That's they do this specific thing that they had us do in my astronomy class in high school. I remember this, where they watch a sun far out and they wait until the light emitted dips just a little bit. And that's how they know that a planet has orbited like just in front of the sun so we could see it. And that's how we discover these exoplanets, or one of the many forms in which we do so. And I mean, with the right technology, anybody could discover a planet. A lot of just regular people who have a fascination for astronomy, they do it every day. Yeah.
And it's interesting that you said that everyday regular people can do that, because we're coming to a place, I think, technologically, at least maybe in the United States, we're listened to in 69 different countries. So I don't know what the capability of somebody in the desert in Africa who's listening to the Space Between, and we appreciate you tuning into the Space Between, but there's clearly just like the general, people in like Western cultures tend to have a little bit more financial ability to play around with technology that maybe other cultures don't have. And I wasn't trying to like single out Africa or something like that, but it's just that was the first thing that came to mind, is that there's a power differential there that separates people from being able to, the quote unquote average person, from being able to experience some of this stuff. But at the same time, cultures in Africa, they get to see the real night sky because there's no light pollution, right? So we in America, we might have access to better technology, but at the same time, we don't actually get to see what the night sky looks like because we've just absolutely demolished our atmosphere with so much light pollution that we don't know what it looks like. We haven't seen what it looks like for 150 years. Meanwhile, our friends in Africa might not have the access to the technology that we have, but they get to see the actual night sky with their naked eyes and just enjoy that beauty. And it's interesting that that technology is starting to become available to folks, so that you could set up your own radio telescope in your backyard and do some of your own radio astronomy. I don't know if the average person has enough access to the technology required to be able to detect an exoplanet. That would be wild. If that would be pretty crazy if you could do that. But the technology exists, which I think is probably the most fascinating part. And you brought up something. It's interesting that you've brought up the movie Interstellar, because we have underneath every one of our episodes, there's a little it's a Q&A, and we are always asking you, what do you want us to talk about? You get to drive the ship, folks. I don't know if you knew this. You get to take the con. Can you tell I've been watching a bunch of Star Trek? I didn't grow up with Star Trek. My wife did, and so she's like, we're gonna watch all the movies, and I'm gonna get you into the TV series from there. And I'm hooked. I grew up watching Lost in Space, Danger Will Robinson. So like that's OG for me. I know Star Trek is OG for a lot more people than Lost in Space, but if we're going to let Mr. Sulu take the con, right? You get to do that too. You get to drive the ship. You get to be in control of the topics that we discuss. And we really appreciate Lucy Poll, or Lucci Poll, I hope I'm saying that correctly, a user that commented on our first episode with David Kipping. And I'll tell you about David Kipping here in a second. But This individual said, could you discuss the star Betelgeuse and her possible impending death or the movie Interstellar, please? So I didn't even tell you that, Jimmy, and you just like organically went right for Interstellar. I love it because Interstellar is a great representation of what multimedia people and journalists and scientists and thinkers, but creatives and people who have a huge imagination and take hard to quantify intangible things and make them tangible for us to see and experience. And that's why I love the movie Interstellar. And I enjoy that you brought that up organically because I was trying to figure out a way how we could incorporate that into an episode, and you just went right for it. So we can talk about Interstellar now. What does that movie do for you?
Well, it really just like it's one of those things. It's fascinating. I love like everyone. What I love about you mentioned earlier the thing about how people in Africa have like this. They get the real experience of the night sky and we don't. What I love about like everyone on Earth is we all don't know just about the same, but we all have different tools to figure it out.
Right.
And I think that's something that I like. Interstellar is a movie that everyone can watch. You don't need to know what's going on in space. You don't need to know, like, you don't have to be a big fan of Matthew McConaughey. You can just go watch the movie. It's not only a brilliant movie, but it's very scientifically correct as we've.
It's scientifically based.
Yeah, it's based. It's based in science at the very least, which I think is. That's what I love about it is it's such a good kind of gateway into astronomy and getting people into it. And that's what I really enjoyed about watching it. I'll be honest, I've been watching like clips of it a lot recently. I have not sat down and watched the full movie actually.
Like ever?
No.
Really?
Here's it. Not to get off in a tangent. I have done this thing. I'll be scrolling through TikTok and I'll come across a movie clip and I'll go, that looks interesting. I'll tap on the account and I'll watch the whole movie. Just scrolling through TikToks. It's not a
just getting the clips.
Yeah, I don't necessarily recommend doing that, but that's how I watched like a lot of Interstellar.
Really?
I spent like 2 hours, and then like they wouldn't post a part of the movie, and I would go, well, I got to go to another account and find it. So I'd like, I would find it. It was insane.
Resourceful.
I know. Not that resourceful. I could just sit down and watch the movie. But I'll tell you what, I loved it. Like I still loved it. I got a lot of the movie, and I thought it was very interesting the way they played, like the end of the movie where he goes into the black hole and he's like in this weird
in the Tesseract.
Yeah, in the Tesseract. I actually have a question for you. How scientifically based is that part?
Man, and that's where I think everybody in the science community kind of chuckled because it's kind of like they're suggesting that Matthew McConaughey. I think a tesseract is like multiple dimensions inside multiple dimensions. And Matthew McConaughey goes into this black hole. And first of all, as I understand it, the leading theories around what would happen if you sent something into a black hole include like instantaneous death, spaghettification, as you get closer. So it's interesting, actually. I watched a video about this. Once you cross through the event horizon, you in some way will permanently, if somebody was on the outside of the event horizon watching and you crossed over, like you just stop moving and then you just suddenly cease to exist.
Yeah, you would, it'd be like you just like glitch out of the universe.
Yeah, but like you would stop moving to them because until that light got away from them and then you would just be gone because you went over the event horizon and all the other data of you moving closer to the singularity at the middle of a black hole can't get past the event horizon because that's where gravity is so strong that nothing escapes. And so there's all sorts of stuff inside of a black hole, but we'll never know what's inside of a black hole because no information can escape the event horizon. And so the idea is that once you go past there, the closer you get to the singularity, the more you get stretched, and then you just get, it's called spaghettification, and you just, you literally spaghettify, and you get torn into little strands, and then you cease to exist. What a painful way to die.
Into a nice linguine.
Yeah, right. And so, you go into a black hole, you don't know, but there's an interesting theory that's been proposed recently. I can't tell you how recently, and I haven't read up on the theory, but the idea is that the inside of a black hole, if you use this special kind of math, actually doesn't spaghettify you, and it indicates a wormhole, right? And so when you hear about something that goes into a black hole, and what if that shoots you into another part of the universe or whatever, there's theories that suggest that could happen. We're so far away from any black hole anyway that we won't be able to like test that anytime soon. And even if you could send something into the event horizon and beyond it, you wouldn't be able to get any of that information out because that's not how physics works. So like you'll never know unless you sent a living thing through a black hole, it went through a wormhole, was able to come back to you and then say, oh yeah, that worked. Like that's like the only way that you could prove that, at least from my very feeble understanding of physics and the way that things work. But for the most part, it seems to me, and again, I'm not a natural scientist. I say that probably every episode because it's just like I'm stretching my own knowledge base here. But from what I've read, I listened to half of a very dry book on black holes, and I just had to stop because it was too much. I was information overload, like rubbing my face against a cheese grater. And I just had to stop. But from what I can understand from this book that I read and some videos that I've watched is that once you get to the singularity, you're just compressed into infinite nothingness. So there you go. It doesn't really matter. So the idea that Matthew McConaughey gets sucked into a different dimension, everybody was like, nice. Because we don't know what happens. And it's very likely that you do not end up in a higher dimension. So,
well, and then he just like becomes a part of the environment for like all of time ever. Like, wouldn't that like,
right?
He starts
and that's
like knocking over books,
right? And that's the Tesseract kind of idea of dimensions inside dimensions. Let me double check that. I'm going to type in what is a Tesseract, and it's going to pop up with like Thor or something.
I don't know. Loki's got it.
Yeah, a tesseract. Okay, so in geometry, a tesseract or a four-cube is a four-dimensional hypercube analogous to a two-dimensional square and a three-dimensional cube. Just as the perimeter of the square consists of four edges and the surface of the cube consists of 6 square faces, the hypersurface of the tesseract consists of 8 cubical cells meeting at 4 right angles.
Wow.
Yeah. So imagine a cube inside a cube that's evenly spread out with itself, I guess. It's a 4 cube. An 8 cell. I don't know how to even explain that. Like the picture makes sense. I'm looking at the picture here on #Wikipedia. I know Wikipedia is not legit, but the picture's legit, and I've seen this picture before. So yeah, a tesseract, and that's what actually Matthew McConaughey says. I don't know if you've seen that part of the movie, but he's like, "Oh, we're now inside a tesseract. Oh, a tesseract," and then there's the implication that higher beings that created the wormhole for them to fly through to save Earth in the first place also created this place for Matthew McConaughey to go to, but all he had to do was figure out that they wanted him to go into the black hole. So like there's this weird like dare I say like religious kind of like there's this otherworldly omnipotent being or collection of beings that influenced McConaughey to go into the black hole to save humanity. I don't know. It's weird. And it's implied that it's like humans in the future were able to go back in the past to manipulate McConaughey and to do this. I don't know. It's there's this weird implication that is very Christopher Nolan left unanswered.
Yep.
Just like, okay, sounds good.
It happened. There we are.
That's about all that we know.
And then he woke up and his daughter was like 80.
But that's the cool part because that's
cool.
That's the cool part because that's the part that actually is real.
Really?
Is that the closer now? Maybe to an extent it's real because again we don't know what happens once you cross the event horizon, but we can say with absolute surety that anything that goes around or gets closer to something that is so heavy that it bends space-time, that time slows down for you while it moves for everybody else.
Well, and that's how it worked when they were on the planet in the first place.
Right, because they were too close to the black hole. So it's like, oh no, we spent an extra 4 hours on the black hole, and then that's why they come back and like the old guy is on the...
Where you been?
He's like, I've been sitting here for 28 years. And it's like, oh no. Oh no, I'm so sorry, my guy. You've been sitting... We were only gone for 4 hours. And that's actual physics, though. Yeah. Like that's explainable by physics and general relativity.
See, that is scary. That part was scary to me, like big time. The idea...
Why? In what way?
I don't know. Just the idea, like, if I'm like, hey, I'll be back. I'm going to this planet over here. And I come back and everyone's like old. Like, that's terrifying. I don't know why that's so scary.
Yeah. And that's why the idea of traveling faster than the speed of light also breaks physics, because it creates a paradox. You would arrive at the place that you were. So let's say you get a message to go somewhere, and that message travels faster than the speed of light, and it goes instantaneously. So let's say somebody at Alpha Centauri, which is one of the closest stars to Earth, says, all right, help. They send a message to Earth instantaneously instead of having to wait the however many light years away Alpha Centauri is. They send it instantaneously, and then the people on Earth travel faster than the speed of light to get back to that place. It's like, I don't think I'm explaining this right. I watched a video about it. It was like, I still don't quite understand what's happening. But the idea is that you would arrive to solve the problem before the message was sent. And so like you wouldn't, it's a paradox. It breaks physics. Like, you can't do that. But that's why quantum physics, and I'm not even going to try and go down this rabbit hole, but that's why quantum physics is so crazy, because with quantum entanglement, with the idea that there's these two particles that are entangled regardless of how far away in distance they are. Are you familiar with this, the idea of quantum entanglement?
A little bit. I'm kind of familiar with quantum physics. This is why I get confused with physics, because it's like, why are you breaking yourself? How is...
Right.
Which is why it's such a tough field to study.
Oh,
I mean, it all breaks itself.
100%. And that's why I think it's so interesting, but I always have to like push it away, because I'm over here thinking my brain's going to explode if I keep trying to ingest this much knowledge about stuff that I don't even remotely understand. But as my very base understanding of this is, and again, it applies back to this whole idea of like the black holes and moving faster than, because you're closer to something that has more gravity, time slows down for you because gravity warps space-time. These particles in quantum entanglement, regardless of how far away they are physically, are entangled. So it has to do with observing the particle. If you observe the particle and it says up, then it's guaranteed that the entangled particle says down.
Wow.
So like and it has to do with observing these particles, because they're always in a state of possible and not possible existence. Which is just like whatever,
Awesome.
like Schrodinger's cat and all this weird stuff, and it just blows off into Rick and Morty land. But the idea is that using quantum entangled particles, if you can identify them, you can send messages instantaneously, regardless of distance. Which is just absolutely broken. Which breaks physics, because it breaks our understanding. You can't, to be able to send messages instantaneously, like you would get the message before the message was even created, which is crazy.
This is why everyone's like, when someone tells me no and says because physics, I'm like, nope. We already broke physics. Let's try something else. It could happen. I'm like, at this point, it could happen. Any like maybe that I bring up could happen.
Well, and that's true. Because think about it, any and all realities are happening at the same time.
Oh,
so
geez.
there's in the multiversal theory.
Oh,
right?
we're getting in the multiversal theory.
I'm not even going to try. I'm not even going to try. I was just messing with you.
I love the whole multiversal like maybe stuff. I love all that.
Yeah,
it's so weird.
We've really gone off the rails from where we were originally going to talk about was planets and stuff. But
Interstellar, good movie.
It's a great movie. It's a great movie.
Really good movie.
It's actually really fairly scientifically founded for all of the stuff that we in some way can test and demonstrate. Science, I was told once by a scientist that science doesn't prove anything. Science demonstrates things. And anybody that says, well, science proved blank, well, no, because like you said, we're always breaking the rules that we've created. Yeah. And some things have stood for a lot longer than others, but who's to say that somebody won't figure out that Newton's laws of whatever don't actually work. Yeah. And that fits in to a different theory that makes everything else work. Okay, fine. Maybe that will happen. So far it hasn't. It seems unlikely that it will, because Newton's laws of thermodynamics have been around for 400 years. So some things tried and tested seem true, but 400 years in the grand scheme of things, a blip on an infinitesimally small line in the middle of nowhere. That's hilariously short amount of time.
Gosh, that's insane. Yeah. It's everything. Wow, my brain's breaking. That's the type of like, we get to this point where everything gets so big and grand, and then I have to remember the Big Bang Theory, and then I'm like, oh boy, Sheldon, and then there's Leonard and the gang.
Oh man.
No,
Well, as your brain breaks, we'll step aside for just a moment. We appreciate you tuning in. Coming up next, more on The Space Between about our actual topic of planets and exoplanets.
In a world drowned in artificial light, the stars above are disappearing, but there's hope. Dark Sky International is on a crucial mission to restore the nighttime environment and protect communities from the harmful effects of light pollution through outreach, advocacy, and conservation.
Light pollution disrupts wildlife, impacts human health, wastes money and energy, contributes to climate change, and blocks our view of the universe.
Dark Sky International fights against this silent intruder, working to reclaim the beauty of our natural night landscapes.
Communities, parks, and regions can earn the coveted Dark Sky Place designation, a symbol of their commitment to preserving our shared night sky.
Your choice of outdoor lighting matters. Be a part of the solution, not the problem.
Following responsible lighting practices, passing dark sky-friendly legislation, and advancing scientific research in this field are just some of the ways light pollution can be solved.
Visit darksky.org to get involved and stand with Dark Sky International in the battle against light pollution. The stars are counting on us.
Well, so we kind of got really off the rails there, but that's okay. You know what? Today's a little bit more on the nebulous side, I guess you could say. I guess you could say we're living in the space between now. Yeah,
that was what a poll. That was crazy.
I think, you know what? God bless you, Jimmy, because every time I say something like this on this pod, at this point, Dawson's like, "Oh yeah, wow," like he's so unimpressed.
No, that's
and you are young enough that you're like, wow, that was great.
Well, that's one of my favorite things. That's one of my favorite things to do is like bring the name of something back into it. Like that's like I love making jokes of like Bob Saget on Full House is just like, wow, this really is a full house, you know, and then the credits roll, you know. That's something I wish they'd do more.
Oh, it's very It's like the lowest form of humor, but I enjoy it so much.
I live there. I live in the lowest form of humor.
It's, you know what? Then we can live there together because that's fantastic. But so thank you for laughing. That made my self-esteem skyrocket. Not really. I'm good. I'm all good. But that being said, exoplanets and kind of the planets of the solar system, but exoplanets specifically. And I'm excited to say that we've reached back out to Professor David Kipping of the Cool Worlds Lab. David will be coming back on the show sometime this year. We're going to reprise. We're going to do David Kipping in the Cool Worlds Lab Part 2. And that's going to be exciting because David Kipping, and we didn't really talk about it in the first episode of the show where we sat down I sat down and discussed a bunch of stuff. This was pre-Dawson. So David and I sat down and discussed a bunch of interesting things from his YouTube channel, The Cool Worlds Lab. Definitely check them out. They have unbelievable content about all of the mind-breaking things that you could possibly want to know. And he explains it in the most eloquent, easy to understand way. It's just fabulous, which is why I love he's like the perfect podcast guest, but he's also dummy busy. And I'm not trying to like hit him over the head with be on my podcast kind of guy, but he so very much understands exoplanets that he's kind of like the father of exomoons in studying to see whether these planets have moons. And like the handbook on trying to find exomoons was written by this guy, which is super cool.
Wow. That's
super cool.
Insane.
It's so awesome. And I love that you brought up kind of the way that in the previous segment, the way that scientists are able to determine whether they think a star is a candidate for exoplanets because of when those planets in its orbit cross in front of the star, then it'll just make the star dim ever so slightly. And in the same Lucipol again, I'm sorry, I can't tell if it's Italian or not. It doesn't look particularly Italian, but thank you for your question about Betelgeuse. we're going to get an actual expert on here to discuss Betelgeuse because I think that's just an absolutely fabulous discussion to have about whether it's going to go supernova or not because of the way that the light fluctuates. It gets really bright and it gets really dim, gets really bright, gets really dim. Some scientists have suggested, well, that means that it's unstable and that what we're seeing is at its actual end stages of life way ahead of when we had anticipated them to be, and it's going to go supernova in the next 100 years.
Wow.
I don't know about that. A lot of scientists are like, pump the brakes there, Chief. We appreciate the commitment to thinking outside the box, but we don't know if that's what the evidence is suggesting. So I'm not going to personally comment on that. From an astrophotography perspective, and I've said this before on this podcast, I think it would be really just unbelievable to see Betelgeuse go supernova, but B, I think it would also be really saddening because every generation of humans ever would have looked up at the night sky and seen Betelgeuse and Orion until that moment, and then it would no longer be there. And it would be something else that faintly got dim, leaves a supernova remnant, and then is never a part of Orion the Hunter. It's like, okay, that's mind-bending right there.
Yeah.
You know, generations of people have, and they've all looked up at the sky and seen that one star, and then suddenly it's not there anymore. Crazy. But I that's all I can say. And that's really all that I can speak on. But we will get an expert on here to discuss Betelgeuse because I think that's a really interesting topic to break down. But what do you know about the way that scientists are looking for exoplanets? Is it just that one bit of information that you shared, or is it something else that has kind of piqued your interest around looking at exoplanets and studying them in your own personal free time?
That is the only methodology that I know of how they look for that type of stuff. I don't know of any other way that they do it, just because that's the way that I did it in my class that I took.
Yeah.
But I know I was actually just looking on the NASA website of exoplanet exploration, and I think they said how many exoplanets have been found? 5,573 confirmed exoplanets so far.
Cool.
But I don't really know how else they look for them besides that.
Cool. So I've actually got some methods for you, some detection techniques. So according to a Google search, it looks like there's 1, 2, 3, 4, 5, 6, 7 general techniques that are used. So it's the transit method, and it's widely used. The technique that involves monitoring a star for slight periodic dimming caused by an exoplanet passing in front of it. The duration and depth of these transits provide crucial information about the exoplanet's size and orbital characteristics. There is, something just popped up on my screen. There is the radial velocity method. So by observing the gravitational tug an exoplanet exerts on its host star, researchers can measure the star's radial velocity, revealing details about the planet's mass and orbit. So that means that if the star is small enough and the planet is big enough, they will exert enough gravitational difference on each other that the star will wobble in its orbit. And so the planet is influencing whether the star wobbles or not. And it's very slight, but they're able to detect that with very high-powered technology.
How have we made technology because all of those things that are happening are so slight, especially with how far away we are. That's insane.
Easy. Aliens.
I mean, yeah, it gotta be. It's gotta be.
That's a discussion for another time, but I would very much like to hear your opinion on that. We'll have to have you back on the show to discuss that. So a couple more techniques. So there's direct imaging. So advancements in telescope technology enable astronomers to directly capture images of exoplanets. This method is particularly useful for studying the atmospheres and surface temperatures and features of large distant planets. There's microlensing. So this phenomena occurs when the gravitational field of an exoplanet causes a temporary distortion of light from a background star. By analyzing these distortions, astronomers gain insights into the exoplanet's properties, which is crazy. So one of the greatest images from the James Webb Space Telescope, and we had John Mather on here just this last year, the senior astrophysicist for the James Webb Space Telescope program, won a Nobel Prize in physics, just a really cool guy. Go check that episode out. He talked about, we asked him, what's your favorite image that JWST's taken? And he said, I love the image that we gave to President Biden to unveil to the rest of the world when JWST finally got into orbit in its Lagrange 2 point. I think it's Lagrange 2 that they sent it out. It's a Lagrange point where they put it out and they took an image and they went deep space. They just said, we're going to shoot deep space image. And they were able to get this wide field of galaxies. But then there's this weird circular thing in the middle of it where the galaxies are bending, and it's because of gravity. and you can see where the lensing is on this image, where the galaxies are bending because of gravity. And it's very, very specific. It stands out in the picture. And he was like, I think that's the coolest image that I've seen from JWST so far, because it reveals the power and the things that we cannot see that are exerting force on us millions and billions of light years away. That's just really cool that we are just in our infancy of learning how to detect. And I love that they're using microlensing as a possible way to detect potential exoplanets.
Yeah, I don't know if I've seen that picture. Like, I think I did.
Really?
I don't know if I have.
I think if you saw it, you'd be like, oh, yeah.
Because I think I've seen, there was the one picture that Hubble took a long time ago.
The Hubble Deep Field.
JWST did the same thing.
It's a great picture.
And that's how we figured out that there were, stars dating back to much farther than we thought. Yes.
Yeah.
Yeah, with the red and everything. I remember that. I don't know if I remember this specific picture that you were talking about.
Yeah, I'm gonna put the picture on the screen right here for you guys to see. And Jimmy, I'm gonna send it to you via text here. I just pulled it off of Forbes.com. But this is the image that I was referencing, and you can see where light is bending around these galaxies. I just texted it to you. But what a really unbelievable way of being able to look into the center of the universe. And,
sorry, didn't mean to interrupt you.
The center of the universe isn't a real thing, but where the part of where the Big Bang is started, I think that's where it was pointing at, because there's this bright part at the beginning. God, I'm just completely butchering all the words that I want to say now. In the very middle of the image, there's this bright part, which I think is supposed to be like either a really bright star or the core of where we believe the universe is expanding from. I don't quite recall. Maybe a galaxy cluster. The first thing that I'm looking at here says gravitational lensing. This is from space.com. The key to weird looking and repeating galaxies is a phenomenon first predicted by Albert Einstein over 100 years ago. I'm just trying to find some information on this picture on the fly, folks, and I'm not doing a great job at it. Gravitational lensing is a phenomenon predicted by Einstein's theory of general relativity, which suggests that gravity emerges from the effect that objects with mass have on the fabric of space-time, united as a single entity called space-time. Think of a stretched rubber sheet. Like, I understand all of that, but I'm just confused as to what the bright thing is at the middle of the picture. But all right, it's fine. I'm just going to have to be fine with not knowing, but it's I'm not bitter. It's fine. There are three other techniques I'm going to just rattle off here real fast. There's astrometry. So the technique involves measuring the precise position of stars over time. The gravitational pull of an exoplanet influences the motion of its host star, allowing astronomers to infer the presence and characteristics of exoplanets. There's pulsar timing, which is really cool. Exoplanets can be detected by monitoring the timing of pulses from pulsars. Variations in pulse arrival times may indicate the presence of an orbiting exoplanet. And then reflection and emission spectroscopy. Analyzing the reflected or emitted light from exoplanets provides information about their atmospheres and compositions. So those are just some of the ways of detecting exoplanets and the way that we're able to see what's going on out there.
Wow. I mean, I think it's amazing that we can even get close to the different compositions and everything. I had no clue that was even a possibility.
Yeah. And that's why the ability to just point a telescope at something and be able to look at it is so huge. And I'm very excited to see what I think it's the Large Magellan Telescope, LMG or LMT, large, type it in here, Magellan. I typed in K's instead of L's. Magellan Telescope, yeah. So the Large Magellan Telescope is a 25.4 meter ground-based, extremely large telescope under construction in Las Campanas, the Las Campanas Observatory in Chile's Atacama Desert. And it's anticipated in the late part of this decade to be complete. And it's just this huge telescope with these big mirrors that allows us to see really deep. And there are things that you have to overcome because of the atmosphere of the Earth that you, like telescopes like JWST will have an advantage on. But just this huge telescope, the bigger the telescope, the more you'll probably be able to see. And that's what I'm really excited is, will we be able to see up close and personal information about some of these more distant exoplanets because of telescopes like Giant Magellan Telescope. I said it was Large Magellan. It's Giant Magellan Telescope. Apologies. So that's exciting. I'm really looking forward to seeing if that's a possibility in the near future.
Yeah, I'd like to see more about the giant marble-looking planet we were talking about earlier, the one that rains glass sideways.
Yeah.
Yeah, I mean, folks, I would highly recommend going to NASA's exoplanet exploration just on Safari or anywhere, and they will show you, they have plenty of just pictures of these exoplanets that we're talking about. Just go peruse through there. It is one of the most, I love doing it.
Really?
Yeah, they do this specific thing. What is it called? It is the Exoplanet Alien Worlds like Travel Bureau.
Okay.
And what they've done is they have they've gotten an idea of what it looks like and the composition of everything on the planet, and they computer generate what it would look like on the surface of that planet. And it's a little interactive, and it'll give you facts about the atmosphere and everything. And it gives you full 360 look around, so you can look at everything. And it is just so cool. It gives you a lot of facts about the exoplanets.
Love that. That's really cool. We'll put that on our website, spacebetweenpodcast.com, under, I think it's our blog. I don't know if it's called blog. I created the website. I don't even remember off the top of my head. But there's a place where we put all of the articles that we reference. So if you want to check that out, you can definitely do that. We're going to cap off today's episode as we begin to run out of time here, that there was an astronomy.com article by Elizabeth Gamillo, or Gamillo. I don't know how she would actually want that to be said. I'm going to go with the actual pronunciation, Gamillo. There's two L's, Gamillo. Jeez, I just came back from Mexico and I can't even say the double L right. Gamillo. I'm gonna run with that. Sorry, Elizabeth, if I'm saying your name wrong. You know what? I'm gonna roll with Elizabeth. God, I'm just overthinking it. It's just too much. This is an article from today, astronomy.com. Recently discovered super Earth might be habitable, and it could have a sibling. So there's a super Earth about 137 light years away called TOI-715b, and it orbits a red dwarf sun. The exoplanet has a mass of 3.02 Earths, so that means it's triple the size of the Earth. It was first found in 2023. The same star system may also hold a smaller, nearly Earth-sized planet. If confirmed, that exoplanet, currently named TIC 271971130.02, will be the smallest habitable zone planet found by NASA's Transiting Exoplanet Survey Satellite. Transiting Exoplanet Survey Satellite, or TESS. The habitable zone is the area found around a star in which temperatures are just right for an exoplanet to sustain liquid water on its surface. So that's fascinating that there's this super Earth, and then there's this little tiny potential baby Earth that's there in the habitable zone.
Well, and the baby Earth is very important because one thing when we always talk about like habitable planets potentially that a lot of people forget is that the gravitational pull of a planet depends on how big it is. So we always talk about, super Earth, more Earth for us. No, that could actually be like really bad and hard on your body if we were, of course, we were to ever find our way to these planets 137 light years away.
Right.
But that's one thing I always think about that is very important to keep in mind, is that you need to make sure that it won't weigh down on you too much when you go there.
That's a really excellent point that I've never actively thought of. that makes so much sense. If it's bigger, that's probably more gravity that's exerted on you. I guess it also probably depends on the makeup of it.
Yeah, that as well. That is a big time.
Well, and so it says in this article, thanks to Elizabeth, I'm sorry, I'm not gonna butcher your last name. It says size is key. That there's the person who was surprised to discover T0I-715b is not only in the habitable zone, but it's also potentially a rocky planet. And that's because to be rock super Earths, which have masses between 2 to 10 times Earth size and diameter, between our planets and Neptune's, need to hit a sweet spot for where they are not too big, but not too small. If they are too big, we think that they're no longer rocky, and they turn into something that looks more like Neptune or Jupiter, which are completely gas and have no solid surface, says Sarah Moran, who studies exoplanet atmospheres at the University of Arizona and was not involved with the study that discovered potentially this smaller Earth. So astronomers need to know, whoa, the page is freaking out. So astronomers need to know both mass and diameter to determine whether a planet is truly similar enough to ours to host some form of Earth-like life. If the planet has a low mass and a large radius, it is likely a so-called mini Neptune with a gassy atmosphere and little rock. If it has a higher mass but smaller radius, it's probably rocky like our planet. And the possibility that T0I, it's either TO or T0I, 7-715b is rocky. According to Moran, that would be exciting because that supports it being more of a habitable planet versus some sort of other world. And I think this is the interesting part because people have wanted to know for so long little green men. And the way that you're going to find little green men is probably not from a signal. It's not something that's beamed to us. It might be. You never know. There's so much time. There's so much time that's passed since the beginning of everything until now that maybe we're being inundated with messages right now and we just don't have the technology to be able to see or hear them or communicate with them.
What song would you transmit to little green men if you were like, you have to send them a song?
That's heavy. I don't know. I really don't know.
I would do like a probably a Sinatra. Good little Sinatra tune.
Some Frank Sinatra just became your intergalactic ambassador.
Yeah, I mean, well, they might be pretty disappointed when they're like, "Oh, we want to come see him sing live," and we're like,
"He's dead."
All we have is this one guy who can do a good impression on America's Got Talent. I'm sorry, that's all we got.
Discount Frank Sinatra.
Yeah, sorry, we got a junior. We got old junior here.
I'd like you to be acquainted with Michael Bublé.
Michael Bublé.
sorry. But I think the study of exoplanets, and I've never really thought that hard about exoplanets, to be honest. I think the study of exoplanets is so important because if you are part of that search for extraterrestrial intelligence, if you are affiliated with SETI, if you just want answers, then studying exoplanets is the way for you to find answers. Now, it's far more likely that we would have gotten something from an Earth-like planet 137 light years away than it would be hundreds and thousands and millions of light years away, because that means that it's needed to go hundreds and thousands of millions of years to get to us, which means that by the time that we would ever be able to get back to them, they're probably not there anymore. So,
well, and that implies that there was good enough technology, hundreds of millions of all
right.
This time
It improves. It improves. It doesn't improve. It just proves. It demonstrates.
There it is.
There we go. Sorry.
Boom.
Sorry, I'm a hypocrite. It demonstrates that there's that word, I don't know, unintelligent apes. I don't know. Like I don't know what more I could say. Like it's just if we got a message from somewhere millions of light years away, it's like, well, we're screwed because we're so hilariously behind the curve. And then even so, just the fact that I had to travel that far and that long to get to where it needed to be. Whatever.
Yeah, they sent that message and we just discovered fire. So,
yeah, right.
I mean,
exactly.
like
Exactly. We just built our first nukes and they're sending us intergalactic messages. Whatever, So we might not be here by the time that they show up. So who knows? I think, and we did an entire episode on this, Dawson and I. What if we're looking in the wrong place for extraterrestrial intelligence and we should be looking for AI? There was an interesting discussion that we had about that. But I think after this just hit me like a ton of bricks as I'm saying this to you, what if the key for the search to extraterrestrial intelligence is quantum physics because of quantum entanglement?
I mean, yeah.
Because of what if we've just barely discovered the thing on which all manners of life are communicating with each other and have been for millions of years because they understand it throughout the galaxy because they can do it instantaneously.
Well, and are you familiar with, I'm going to butcher this because I haven't watched a video on this in like a year or two.
It's all good.
Are you familiar with the like hierarchy of how they classify different species,
like a type 1 civilization.
Yeah. I think, what are we? We're only type 1, right?
Yeah.
But for all we know, I mean, we have never seen a type 2 before. We don't use all the resources on our planet. We don't know what is like in the ocean.
It's so hilarious to me that we say things about space with such confidence, and we're like, "What's at the bottom of the Marianas Trench?" And you're like,
SpongeBob. Glove World. Final answer.
Whoops, I just kicked my mic. I just watched the Super Bowl. I know what lives at the bottom of the sea.
A big elevator.
Right, exactly. Satan. I don't know. Like something.
Whatever those monsters in Pacific Rim came out of. That's at the bottom.
That's it. Fire movie, by the way.
Another great movie involving robots.
First Pacific Rim is a fire movie.
So
the other
good.
one are dumb. But
I didn't even watch the other one, but I do like John Boyega.
Man, it's dumb.
Yeah.
I was very disappointed.
Well, I'm never going to watch it. Probably. I'm one of those guys. I'm like, so I need to be in the right position. I need someone to go, we're watching this movie, and I'll go, sure, I guess. Seems like I've been overtaken.
You're vibing. Like you always do.
No Mario Party for me. Movie time.
Movie time, indeed. Well, it's just one of those things where I'm making the bold prediction now that our first extraterrestrial intelligent contact will come through quantum entangled messages because they will be able to travel great distances instantaneously.
And it'll be via Apple Vision Pro. FaceTime.
Apple sponsor us. No, I'm kidding. But hilarious. I thank you for throwing that in there. It'll be a mix up between Apple Vision and Gork or whatever it is.
Grok.
from Grok. Sorry. This shows you how much I actually pay attention to Twitter anymore.
Yeah, I've only seen it on Twitter, and
Or
every time I'm like,
X.
Gronk.
Gronk.
Oh.
It's Rob Gronkowski.
It's Rob Gronkowski.
Bro, I would pay way more attention to it if Elon Musk put out a Rob Gronkowski AI.
And it's trying to get me into USAA, and I'm like, sorry, man.
USAA. That's probably a copyright violation. I'm not going to worry about it.
Sorry.
Yeah, sorry. Don't sue us. At any rate, well, I'm excited about exoplanets. I'm excited about having David Kipping back on the show sometime this year to be able to talk about that. I'm excited about bringing you more on the show, Jimmy, because you've been electric today in Dawson's absence.
Yeah, thank you so much for having me. I love talking exoplanets, interstellar, Real Steel. I love it all. You know?
Real Steel, another underrated movie. You won't hear that, but we were talking about that in our little break, and he likes it. He likes this movie a lot.
Very good movie.
It's a very good movie. All right, I'd rather watch Pacific Rim, but it is what it is.
Yeah. You know what? I'll accept that too.
Well, I'm the host of the show, so you better accept it, Jimmy. No, but anyway, Jimmy, where can we find you on social media and get a hold of your podcast?
Yeah, Dialed In Podcast on Spotify. I want to move it over to Apple Music. I just need to do it.
You can do both at the same time.
That is true. Well, I'm saying I just need to expand a little bit. Need to go on YouTube. At the moment, Dialed In is just on Spotify. You'll be releasing this Monday. About Tuesday, expect we're dropping a new episode. If you're a K-State fan, we're dropping a new episode with Aoka Lee.
Oh, whoa!
That'll be very cool.
Whoa! How did you land that?
Texted her.
Wow, major dub.
So we'll be doing that. That'll be cool. Follow me on Twitter at Jimmy Kaufman 12, capital J, capital C, and there's no capital numbers, so that's fine.
Roman numerals.
I post a lot K-State sports and any music stuff. Big music guy. And then follow me at James C. Kirk 17 on Instagram. That's all lowercase, all that stuff, and I just post little fun pictures there. So
nice. Well, Jimmy, appreciate you coming by the show. If you want to check out Space Between and our social media, you can do that at Space Between Pod, P-O-D, on both Instagram and TikTok. I'm just kind of like not doing anything with our Facebook page at this point because it's too much work. Facebook's too much work. I can't do it. Instagram, TikTok, it's all kind of generated in the same way. I can work with that.
Well, and when you post something on Instagram, there's a little tab thing that says post on Facebook too.
Yeah, I know, but it's currently connected to like the wrong account. I don't know how it's connected to my personal account, and I don't know how to. I've been messing with it for like 3 days, and I can't get it to. So I'm like, you know what? Just screw this. Facebook and Instagram, they're all part of the same thing anymore now anyway. So I'm just going to put it on Instagram. We get better engagement on Instagram, but we get better engagement on TikTok anyway. So
it's all in the metaverse.
There we go. It's all in the metaverse. Well, appreciate you tuning in to today's episode. Kind of off the rails. Dawson wasn't here to keep us on track. That's okay. Had a blast doing it. Anyway, go check us out. Space Between Pod, P-O-D, at Instagram and TikTok. If you also want to check out our Patreon and get our exclusive content, you can do that. We'll be dropping exclusive content for the VLA. If you want to check out any of that, go to Patreon, go to our website, www.spacebetweenpodcast.com. Join our Patreon, $2 to $5 a month. Easy money. Easy money. We want to see you there. Appreciate you tuning in. My name's Kolby Van Camp. Here with Jimmy Kaufman, filling in for Dawson Wagner. You've been listening to The Space Between.